Hi, class. Today we are doing 16.4 more proofs. These proofs are congruency proofs with parts. So what that means is we're going to prove the two triangles are congruent first. And because they're congruent, all their corresponding parts are congruent. And if all their corresponding parts are congruent, then we can state these angles are congruent, these sides are congruent. And as you continue through the assignment, you're going to notice that with these, we have five examples to do: angles, sides. So we're proving now not that the triangles are congruent, or we're asked to prove not that they're congruent. We're asked to go a step farther and state that corresponding parts are congruent. Now that's easily done as long as we know the triangles are congruent. We can easily state their corresponding parts are congruent. So CPCTC stands for, and we've already talked about this before, if I remember right, corresponding parts of congruent triangles are congruent. That's what that means. And that's pretty cool. If corresponding parts of the congruent triangles are congruent, then we can use that when we're asked to prove that parts are congruent. So any type of parts. Now we know we have 6 different sets of congruent parts. We have angles that are congruent, they're corresponding. We have sides, 3 angles that are congruent, and they're corresponding to each other. And that's what we know. But first, we have to prove that the triangles themselves are congruent, because we can't state any corresponding parts are congruent until we have said that the triangles are indeed congruent. So if you look at number 1, you're given that AB is congruent to AD. Again, we're going to do just like our last lesson. We're going to mark and analyze, determine what we need to do to prove which way we are going to use to prove that the triangles are congruent. So AB is congruent to AD, and then BC is congruent to DC. So we know those 2 sets of sides are congruent to each other by given. And then we also know that this third side is a reflexive shared side, so it also is congruent. So with those 3 sides that are congruent to each other, we know we can prove the triangle congruent by side, side, side. Once we do that, even though all we know are the sides are congruent, they are congruent, the 2 triangles by side, 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 then we can state what we're asked to prove, and that is that angle BCA is congruent to angle DCA. All right? All right, so let's go. So AB is congruent to AD. It looks like if we state that side, that side, that side, triangles are congruent, angles are congruent. Looks like they're doing separate again. Usually, if it were me writing out the proof, I would state them on the same line, but that's right. So those 2 sides are given that they're congruent, and we've marked those. And then we also have the third side, which is this reflexive side, AC and AC. So we always look at how it is stated. If I go AC, I have to make sure that in the second triangle I use the correct order. So last to second place, I need to go last to second place in stating AC is congruent to AC. So that is the reflexive property of congruence. All right, and then because I have side, 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 and I've stated each of the corresponding sides that are congruent, then I know that triangle BCA is congruent to triangle DCA, and I'm just using the same order that the proof statement gives me, because I can count on that one being stated correctly for my congruency statement, and might as well use it, right? We'll just put triangles out front. So we're stating that the triangles are congruent by side, 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 and because the triangles are congruent, we know for sure that these 2 angles, corresponding angles, angle BCA is congruent to angle DCA, and that's by our little proof statement up here, CPCTC, which is the coolest one ever. I'm going to highlight it because that one's important, CPCTC. All right. Okay, next one. If you're given this information, again, we take the given, we mark, we figure out how they're congruent, and then state they're congruent by each of the sides and angles that are congruent, and then state the sides are congruent, so that we're asked to prove are congruent. So PS is parallel to QR. So I like my little blue lines for parallel. I don't know why, I just started it. Now I'm just going to keep going with it. If those two lines are parallel, what does that tell us? Right? That tells us that if I have this transversal, and I'm picking this one, not the two sides, just that transversal, because I have an angle inside of each triangle that will be congruent to each other. I know this angle between the parallel blue line and this transversal, and this angle, right, are alternate interior angles, and so they're going to be congruent. Okay, we're also given that QPS, so this angle is congruent to SRQ, this angle. And the reason those are congruent is it's given, but then we know one more thing. Right now we just have two angles, and that's not a congruency proof theorem, is it? Angle, angle, it's not. But I know the side between them is congruent, and it's because of the reflexive property that it is. So we can now see that as we go around, we have an angle, angle, and an outside side. So angle, angle, side is what we're going to prove the two triangles to be congruent with. All right, so our given is PS is parallel to QR, and that's given. And from that information, we note that these two alternate interior angles are congruent. So angle PSQ is congruent to angle, I started with 2, so I have to start to RQS. And that's by the fact that they're alternate interior angles. So alternate interior angles theorem, that they're congruent. And then we also have a given that the two outside angles, P and R, the angle QPS and angle SRQ are congruent by given. So I have an angle and the angle. Now the side, I still have to state. So side QS is congruent to, now I'm going to say QS, so SQ is the correct order, because in the congruency statement up here, I mean, it's an angle, but everything will be in the correct order because it's in the given, and I can just use it QS, SQ. Notice how they're flipped? So I have to state that flipped in my proof statement here. So that's our side. So I have an angle, angle, side. So, and that was reflexive property. Sorry, I forgot. Still need to write the reason. Reflexive property of congruence. And then because of angle, angle, side, my triangles are congruent, I'm just going to use this and throw a triangle out front. Triangle QPS is congruent to triangle SRQ because I know it's right in its order, and that's by angle, angle, side. And now that I have my two triangles congruent, then I can state that PQ, side PQ, is congruent to side RS by CPCTC. All right. All right, moving on. Number 3, again, analyze and mark. So X is the midpoint of both YW and VZ. So we have YW, meaning that WX and XY will be congruent, and VZ. So VX and ZX will be congruent. Oh, I better give them a double mark, set them apart. All right, the only other thing that we don't have, but we still know, we're expected to know, is our vertical angles are congruent. So this one is a side angle side, right? So side angle side. So first we state that X is the midpoint of WY and VZ, and that's given. Okay, and because it is the midpoint, then we note that our two sets of sides are congruent. So WX is congruent to, if I go WX, I'm going to go YX in the same order, outside to in, outside to in. And that's by definition of midpoint. And then I also know that these two are congruent. VX, again, they're kind of reflected over the point X. So VX and then X. ZX will be congruent. Have to put that in that order by definition of midpoint. All right, and then I have to do the angles. So angle, oops, I need an angle statement first. Angle W, so I'm starting at the blue or the single mark, WX and V will be congruent to angle, I have to start at the blue again, YXC. and that's because they are vertical angles. And then I can just use my triangle XWV is congruent to triangle XYZ. I'm just using the same order because I know it's right. And that's by side angle side. All right, and now that my triangles are congruent, I know that my angle XWV will be congruent to angle XYZ by CPCTC. Because my triangles are congruent, the corresponding parts are congruent, triangles are congruent. All right, next we'll move on to number 4. JM bisects angle KJL. So JM bisects KJL, that's this and this angle will be congruent by definition of bisector. And then these two angles, JMK, so that's right here, JMK and JML right here are congruent. And then I know my reflexive side are congruent to itself. So I have angle, side, angle, don't I? All right, cool. So JM bisects angle KJL, and that's given. And from that given information, we know that these two angles are congruent. So angle KJM is congruent to angle LJM. And that's because of definition of bisects, right? And then the next thing we'll state is just our other given, our other angle. Angle JMK is congruent to angle JML. That's given. And then those take care of our two angles, and our side is JM. And it's going to be congruent to 1 to 2, so JM again. We don't have to flip them this time. And that's by the reflexive property of congruence. And then our triangles are congruent, and I'm going to use this statement in order to state that. So triangle JMK is congruent to triangle JML, and that's by angle, side, angle. And because they're all congruent, then JK is congruent to JL. That's the two sides that we don't know, this side and this side. And that's by CPCTC. All right, moving right along. BC is parallel to EF, so that means these two are parallel. Now, we have two transversals here. We have this transversal with alternate interior angles congruent, and this transversal with alternate interior angles congruent. Both sets are contained within the triangle, so that's cool. And then D is the midpoint of BF. So I need to find BF, that's this side. And if D is the midpoint, then that means this side's congruent to this side. So that's angle, angle, side. All right. So we're going to say BC is parallel to EF, and that's given. And from that information, we knew that angle B is congruent to angle F, and angle C is congruent to angle E. And that is by definition of, not definition, sorry, they're just alternate interior angles. I think I've done that before. Alternate interior angles. Alternate interior angles. All right, and then we also know that that D is the midpoint of BF, and that was given. And from that information, we know BD is congruent to, we have to go FD, outside, inside, and that's by definition of midpoint. And then, I only have 1 minute left here. So with that, the two triangles are congruent. So you can say triangle CBD is congruent to triangle, I have to start here, EFD, by angle, angle, side, and then BD is congruent to CD by CPCTC. All right, so with this, we have homework, and your homework here is really great. You can go get the labels from the front desk and use them. All right, good luck with that. I'm going to hurry and hit stop.